Quick, think of an animal. Did you think of something furry, like a dog, a rabbit, or a bear? Maybe you thought of an animal with feathers. Most of us think of one of two groups of animals, mammals or birds. Why? I bought this card game for my niece. First 100 animals. I wonder what's in here. There's one frog to represent all amphibians, one turtle to represent all reptiles, and one fish to represent all, well, fish. There's also 5 feathered friends: duck, hen, penguin, owl, parrot. And a dog, cat, bear, giraffe, horse, a bunch of furry animals. For my 1-year-old niece, it will become normal to see more mammals and birds than any other type of animal in her life. In real life as pets and in parks, but also represented in clothes, toys, film, and so much more. And this has happened to all of us, to the point where we have a cognitive bias in our perception of biodiversity. We think there are more species of mammals and birds than reptiles or fish because we see so much more of these, not because there actually are more. You're now in for a treat that will open your eyes to all the possibilities the real world of animals offers. As Mark Twain wrote, truth is stranger than fiction. So let's leave our biases aside for a moment and explore what really is out there. We can picture the real proportions of biodiversity as something like this. These little squares represent numbers of species, and here we can see all the mammals, amphibians, birds, reptiles, and fish. Let's start with what's familiar. Scientists have described more than 6,000 different species of mammals alive today. In our little set here, we can represent them all with a grand total of 7 squares and a quarter. Humans are just one species among all of these. What about frogs? Scientists know of about 8,000 species of amphibians alive today. In our scale, that's 9.5 squares. There are even more species of birds, close to 11,000. These are almost 13 squares. Reptiles are even more diverse than birds. There are more than 12,000 of them, 14 squares and a quarter. Finally, fish. There are almost 34,000 species of known fish alive today. That's 40 of our squares here. This is a more representative view of the numbers of all vertebrate animals. These squares here are animals that don't have a vertebrate, but are the closest relatives to vertebrates. Because we all have a dorsal nerve cord, scientists call this whole group chordates. If we put all chordates neatly together like this, we fit into 3.5 larger squares. But hey, where are the rest of the animals? Using that same scale, these yellow squares are all the other animal species we know of, alive today, sharing this planet with us. Who are they? Mollusks, a group that includes snails, octopuses, and abalones, use 6.5 squares. Arachnids, the group of spiders and scorpions, use 5 more squares. Crustaceans, the group including crabs and shrimps, use another 3. 1 whole square is used by millipede species. 7 more squares are used by a variety of animal groups, like sponges, corals, jellyfish, and anemones. But one group encompasses all the remaining 48 squares. Insects. Planet Earth is truly planet insects. There are many types of insects, but one dominates above all others. Beetles comprise 16 squares. The second most common group of insects is the one with flies and mosquitoes, with a little more than 8 squares. Butterflies and moths follow closely, with a little less than 8 squares. Then comes the group that includes bees, wasps, and ants, 6 squares. 22 smaller groups, like the grasshoppers or the dragonflies, occupy the last remaining squares. Of course, animals are not alone. For example, there are almost 400,000 described species of plants, and more than 150,000 species of fungi. Our planet's biodiversity is much broader than what we imagine. Expanding our narrow view is extremely important, especially in this age of rapid biodiversity loss. Because how can we protect species if we don't even know about them? Let's look at what we do know. Not every species' populations, trends, or threats has been studied, but we know enough about some groups that we can estimate how much of them is under threat. Birds are the least threatened, with 12%. Reptiles follow, with 21%. Then mammals, 27% are threatened in some way. And the most of these are amphibians, with 41% of species currently under threat of extinction. However, only 3/4 of fish species have been studied, which means there's so many species we don't know about that we can't even estimate how much of this group is threatened. We simply don't know enough. And if that seems worrying, look back at this. Of all other animals, we know the status of just 2% of these species, We also have data for just 18% of plant species and 0.5% of fungi. We cannot estimate the threat status of any of these groups. There are huge gaps in our knowledge of biodiversity, and they are unequally distributed between groups. This type of cognitive bias is called taxonomic bias. Most species remain unknown or unstudied, and a few attract all the attention. The public loves them, governments fund their conservation efforts, and researchers study them. But rare, small, or uncharismatic creatures play crucial functions in ecosystems. Our narrow focus is not just bad for the ignored majority, it means we cannot develop efficient conservation plans. We need to broaden our perspective to better protect our planet. All these species here are only the 2 million that we know about, but scientists are discovering around 18,000 species each year, and a good estimate is that there are actually around 10 million species living on Earth right now. So we know just this little area here. There is so much yet to discover. We know some things, like how many mammals are endangered. We have a lot of known unknowns, like how many insect species are endangered. But there are so many more unknown unknowns. What else is out there, and how are they doing?